Greetings, math fans. All right, today what we're going to do is we're going to graph functions given pieces of information about the graph. Okay, so I'm going to give you guys information about is it increasing or decreasing, to give you information about f prime, f double prime, the f graph itself. And so let's start out here real quickly. What you're going to do is you're going to find critical values for f prime and f double prime. Okay, so the first thing is when f prime is equal to 0, even if not an extrema, because remember that's a candidate when f prime is equal to 0, so I'm going to put this in parentheses. It's a candidate, not necessarily guaranteed, right? So even if not an extrema, we still use for increasing and decreasing intervals, right? So in other words, if it's if I had something like this and it was plus plus, and this was, let's say, 5, you wouldn't tell me from negative infinity to positive infinity it's increasing. You would tell me it's from negative infinity to 5 union 5 to positive infinity. It's increasing. Okay, because f prime of x is greater than 0. Okay, so that's the first thing. And the second thing is when f double prime equals 0. And then again, this is a candidate. It's a candidate for an inflection point, right? But even if not an inflection point, it's still used for concave up and down intervals. Okay, same thing, right? I could put a 5 here and a plus, and you would tell me it's concave up between negative infinity and 5, union 5 and infinity. Okay? And of course you would say because f double prime is greater than 0. Okay, so let's try an example here. This is a chart that I'm going to give you, so I'm going to try and fit it all here on this page. And actually, just for lack of time, I'm going to fast forward after I'm done with this. So I'm going to fast forward it, and you'll be able to just see the chart right away. All right, but here's the chart. All right, so here are my charts. Let me talk a little bit about what these charts are. The first chart on the left-hand side here, math fans, is basically just giving you actual values. When x is 2, 3, 4, 5, and 6, I'm giving you the f value, f prime, so slope of the tangent, and f double prime, slope of the tangent's tangent, or concavity, right? All right, and then the next one is interval, so that when you see that 2, 3, that's between 2 and 3, f prime is negative, between 3 and 4, f prime is positive, etc., and I give you that for both f prime and f double prime. So let's make a nice graph here. And this is what you're going to find. So this is kind of all the work here. And we got 1, 2, 3, 4. And we're going to go out to 6. Okay. And basically, the first thing you want to plot here, math fans, since I'm giving this to you, you want to plot the coordinates. Okay. A lot of times you're not even going to be given the coordinates. You kind of have to not really estimate the y values, but kind of have an idea of what it's going to look like. But in this case here, I actually give you, especially in this column right here, or this row, I give you the coordinates, right, the x and the y. So we're going to have 2, 3. And then we're going to have 3, 1. And then 4, 4. Okay, and then 5, 2. and then 6 comma 0. Okay, so now what we're going to do is we're going to use some of this information. And I'll tell you, concavity is just really important to be able to graph things. It really makes things a lot easier. But anyway, let's just use the whole thing. I'm not even going to use so much this chart anymore on the left. I'm going to use I'm going to look at my intervals here. Okay, so between 2 and 3, it's decreasing, so the slope is negative, and it's concave down. So between 2 and 3 is concave down. So this actually is going to help us out a lot with graphing. I'm going to use black again to graph. So it's concave down, it's decreasing. So concave down. Okay? And then between 3 and 4, it's increasing, and it's still concave down. So that's actually kind of nice. That increase, I know it's increasing, so it's going up, but it's still concave down. So draw it concave down, like this. Okay? And then between 4 and 5, it's decreasing and it's concave down. So it's still going down like this. Then between 5 and 6, it's still decreasing, but it's concave up. So that helps you draw it like that. Okay, that's what your graph looks like. So let's look at a couple different things here. First of all, right here, it's kind of nice. It does not exist for the derivative. And sure enough, what is that, math fans? Okay, that is a cusp. All right. So it shows that it doesn't exist at that point, but it is a minimum value, relative min. Okay, so that's kind of just proving that back in the day when we did our testing, we always looked for where it was undefined or where it was 0. In this case would be undefined. All right. Okay, so that was kind of a lot of work just for the chart, but you kind of have to know what's going on here. So here's some more information. This is, again, using a graph behavior to sketch a graph. Okay, so again, I'm going to pause this and then just write it out and then resume it. Okay, so here's the graph, math fans. And again, this is using graph behavior to sketch the graph. Basically, what we see in parentheses is your interval, okay, between negative infinity and 0, 0 and 2, 2 and 4, etc., etc., okay? And then where separately you see x and y coordinates. So obviously, what's the first thing you're going to do is you're going to plot the x and y coordinates. It makes sense to do that, right? So let us graph this. All right, and we're going to go 1, 2, 3, and then 1, 2, 3, 4, 5, and 6. Okay, so let's plot 0, 2, and 2, 1, and 4, 2, and 6, 3. Okay, so let's see what's going on between these. Between negative infinity and 0, it's decreasing and it's concave up. So that means it's coming down, but remember, it's easy. Think of concave up. It's going, it's like a cup, right? So it's concave up, so it's going to look something like this. Okay, and that's going to continue on like that. And then between 0 and 2, it's still decreasing, and it's still concave up. All right, so it's going to be like this. And think about it, math fans. Look at this guy right here. At 0, 2, it's undefined. Sure enough, what is that? Okay, kind of drew a little bit like this, but what's this? What is this right here? Don't you guys agree that's a cusp? Okay, so just kind of give a little idea of what that looks like, right? Keep going here. At 2, 1, it's a horizontal tangent, so there we go. I drew it that way already, and if it's a horizontal tangent, then it's going to go back up again, and sure enough, between 2 and 4, it's increasing and concave up. So increasing and concave up. And then at 4 and 2, it's an inflection point. Okay, so that means if you look at the next one, at 4, between 4 and 6, it's increasing, but it's concave down. So it's increasing, but it's concave down. So this point right here, was an inflection point, so that's why it's going from concave up to concave down. Okay, and that's our graph. Okay, there's a lot of stuff to write out here, but again, it's just kind of looking to see what's given, looking at your concavity, looking at increasing, decreasing, coming up with the graph. Okay, and it's an endpoint because I don't have anything listed other than between 4 and 6 being increasing and concave down. All right. Couple things I want to remind you guys about, and then we're going to do one more example that just to kind of review absolute extrema. Okay, so this is just a reminder that S of t, which is our position, that's equal to f of t. That's the original function. And then we have our velocity. Okay, velocity, that's equal to f prime of t, right? It's the change in position. And then we have a of t, which is our acceleration. That's the change in velocity, which is f double prime of t. And of course, you guys remember, I don't need to write this out there, but we have our f double or triple prime of t, which is a jerk. Okay, so it's kind of a good way to call somebody a jerk. Just call them a third derivative. Very evil. All right, this is just one extra example for you guys, those of you watching the video, and it's just a review of relative extrema and absolute extrema. Okay, you need to realize, math fans, if I just say, hey, give me the maximum value or the minimum value, I'm talking about absolute, right? Because if I just said, hey, here's this function over this closed interval or over this open interval, what's the maximum value, what's the minimum value? Okay, that's not saying relative, that's saying, hey, I want to know what the maximum is, I want to know what the minimum is. So that is absolute extrema. Then, of course, you have relative extrema, which I actually have to say, give me the relative extrema or give me the local extrema. That's another word I believe that the book uses. So just a quick review here. All right, so we're going to plot a few points here. Actually, it's there and there. So it looks like this. Okay, that's cool, kind of rough graph there. Okay, so let's talk about relative max. Okay, what's relative max? Well, that's this point right here, isn't it? Okay, so it's going to be at relative max at 1, 1. And what about relative min? Okay, well, it's going to be right here at 2, -1. And then absolute max, what's that going to be? Of course, that's going to be, you're going to look at it like this guy here. But what do you know about it? Since it's not defined, since the absolute max is not defined, you are going to say that this has none, no absolute max. Okay? And then absolute min, of course, is truly our minimum value, which is defined right there. And that's going to also be same as the relative min, which is 2, -1. Okay? Just kind of a quick review here. So here's a function, y equals 12x minus x cubed. And I'm going to tell you it's between -2 and 5. That's my interval. So a nice closed interval. And I want you to find relative and absolute extrema. Okay? So let's give it a shot here. Y prime is equal to 12 minus 3x squared. Set that equal to 0, so I get 3x squared equals 12. X squared is 4, so x equals plus or minus 2. Okay, do a little interval testing here. And we get, if I plug in negative 3 here, and I plug in 0, and I plug in 3, we test and we get negative, positive, and negative. Okay? And, but this is the deal here, math fans. This was actually really, really important. Okay? You're given an endpoint. And so I know if you guys were looking at this, you would say, well, this is a minimum point and this is a maximum point. Okay? But, first of all, this can't be, since that's an endpoint, it can't be a relative extrema. Okay, so not relative extrema. So, let's take a look at what we have here. And of course, now we're going to plug in our endpoints. Well, this guy right here, we still have to check and see what they are, right? Because that's truly an endpoint. So we're going to have really 3 points I'm going to check. First of all, this 2 right here, it's going from positive to negative. So you guys agree this is a relative max. Okay, so let's list everything. We have a relative max, and that's going to be at 2, 16, right? I take that 2 and plug it back into the original problem. Okay, I have, let's just check out this negative 2. So it's negative 2, comma, when I plug the negative 2 in there, it's negative 16. Okay, and I'm going to test my other endpoint, which is 5, and if I plug that in, I get negative 65. So it actually turns out that's really nothing. Right, because it's not a relative extrema because it's an endpoint, and it's not absolute because it's not the lowest value. So truly, my absolute minimum value is 5, negative 65. Okay, and look at my absolute max is actually 2, 16. So they share that with the relative max. Okay, so that's why it's important to check your endpoints. Remember, relative extrema can't be an endpoint. Absolute value, of course, can be as long as it's a closed interval. And in this case here, the relative max and the absolute max are the same, and obviously one absolute min for this one. And that's it. It's just kind of a quick review, but remember, if I give you some intervals, check those endpoints. You've got to check the endpoints to see if you have an absolute extrema at those points. All right, and also be careful. This can be a little confusing. This guy right here, math fans. Okay, because people love to check it out on the left side and the right side, but truly I don't even need to check that out because I know that I can't have a relative extrema at negative 2 because it's one of the endpoints. Okay, that's it, math fans. Have an outstanding day. Goodbye.